All right, 846. So since there's only 9 problems, I know you guys are sad. I'm only going to do 2 of them for you. So let's go ahead and take a quick look at number 3. So the purple is, I'm going to graph the equation. Y is equal to x plus 2. So y is isolated, so it's already in slope-intercept form. So, y is isolated, so it's already in y equals mx plus b form. So in this, y is equal to x plus 2, right? That's the same thing as saying y is equal to 1x plus 2, right? Because 1 times x gives me x. Therefore, my slope is equal to 1. Okay, therefore my change in y over my change in x is equal to 1 over 1. And my y-intercept, of course, is 2. So let's go ahead and get this over with. We're going to go and graph this guy. So if I call those my axes right there. Okay, let's go back and grab the purple again. And I have a y-intercept of 2. I'm right here for my y-intercept. There it is. And my slope, so my change in y, I go up 1 over 1, up 1 over 1. So there's my points. I connect those dots, and there is my line. All right? And then I'm over here, and let's go ahead and do this one. So this is the same thing as saying y is equal to negative 1x plus 2. Right, because negative 1 times x is negative x. Therefore, my slope, which is my change in y over my change in x, is equal to negative 1 over 1, which is negative 1. And my y-intercept is equal to 2. So I am right there for my y-intercept. And in this time, my slope is negative 1, so I go down 1 in the y direction and over 1 positive in the x direction. Down 1, that's my negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. I'm actually having fun. It looks cool on this thing, huh? And I connect my happy little points there. And I can see, that obviously my point of intersection is right there. And that point is 0, 2. And you can see they both, in fact, had the same y-intercept. And it's my y-intercept that is my point of intersection. All right, that takes care of that one. I'm going to do one more for you. All right, so let's go ahead and take a look at these 2 lines. So this is number 5. So I'm going to start with the purple one, which says y is equal to 2x plus 1, because that's already, y is isolated, so I'm ready to go. Therefore, my y-intercept, obviously, is equal to 1. So let's go ahead and put in our axes here. There they are. And now I'm going to put in go back, grab the purple, and my y-intercept is 1. So there's my y-intercept right there. And now my slope, which once again is the change in y over the change in x, is equal to 2, which I'm going to write as 2 over 1. So I'm going to go up 2 and over 1. So I'm going to connect those dots now. And there's my graph, and it looks like that. So there's my purple line. Okay? And now let's go ahead and solve the orange one. So in the orange one, it's not as simple. My y hasn't been isolated for me, but it's not that hard to isolate it, right? Obviously, I'm multiplying my y by 2, so I'm going to have to divide every one of my terms by 2. So when I do that, I get y is equal to 2x plus 1. Now, my y-intercept is equal to 1. So I have that point right there. And my slope is the change in y over the change in x. Well, obviously that's equal to 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And lo and behold, I have this line right here. So they work out to being the same line. And you can see when I had put them in slope-intercept form, right, I actually got the exact same equation. So it makes sense that when I graph the same equation, I get the same line. So in this one here, right, the answer is, to solve. So it's an infinitely, it's always a little bit of a struggle for me to spell that word. Many solutions, and I say that it is every xy pair such that y is equal to 2x plus 1. And that's it. There you go. That's all you have to watch today. Doesn't that make you sad, guys? I will see you on the flip side.